All right, welcome to 10.4. What we're going to focus on today is solving written problems. So think about word problems. So it should be fun and exciting. We're going to take it easy to start and kind of progressively get a little bit more difficult. All right, so as you solve these written problems, a couple things just to keep note. First thing we're going to do is obviously try and understand the problem. So step one, read the problem thoroughly, try and identify all the things in there. Express the unknown with a variable. So we're going to have something within these problems that we're going to solve. So we're going to give that thing a variable. It might be as simple as defining as x. We might be talking like the width or the length of something. We can define it with a w or an L. So express what the variable is going to be. We can make a chart or a diagram, draw a picture if we need to make sense of the problem. And it says write an equation or find the right formula. So maybe within the problem, like it might be a perimeter or something, or maybe we just based on the words can come up with an equation that expresses the variable in relation to some of the other things. Or maybe it's making use of a known formula, I should say, like area or perimeter, or some of the formulas we've done throughout the chapter. Once we figure out what the equation formula is, we are then going to substitute our values in and solve for the unknown variable. And then we're going to make sure our answer we express with the proper units. And then we should be able to roll from there. So these are the steps we're going to use to solve word problems. All right, so kind of jumping into some examples right away. Again, like I said, we're going to start easy and work our way up to it. So the first one we're going to do is kind of just an expression written out in word form. And our goal is to express what the variable is, write and solve an equation to then solve the problem. So it says here that 7 times a certain number is 42. And I want to know what is the number. So what we're going to do first is define a variable. So in this case, I'm just going to use the variable x. So we'll say that x represents a number. We don't know what that number is. Now it says here that 7 times a number is 42. So again, some of you might be able to solve this without doing much, but just to kind of get used to the process. Now that I've defined a variable, next thing I'm going to do is I'm going to set up an equation. This one, I don't really need a diagram to draw this out. But I'm going to set up an equation to solve this as 7 times a number. So 7 times a number, I can write 7 times x. And 7 times a number is 42. So whatever I get by multiplying those two, I would get 42. So there I wrote an equation, and notice that I used the numbers, 7 and 42. I've shown the operation of 7 times x using parentheses equals 42. Then now I'm able to solve for x by just simply dividing both sides by 7, and I would get x equals 6. So in this case, the number would be 6. And this is just a basic algebra problem, so there's no units involved here, but I know my value or my unknown is 7. Next one, now we have step it up a notch. Now we're kind of applying it to a certain situation. So it says find the length of a side of a square if the perimeter is 66 feet. Okay, so thinking about this one, I might draw a picture first, but what we're going to do first is find the length. So I'm going to say that L is going to be the length of the side. Sorry for my handwriting. So L is going to represent the length of the side of a square. Okay, now we're given the perimeter is 66 feet. Now if it helps you, we can also write down here what we are given. We're given that the perimeter already is P is 66 feet. Now how do we make sense of this? What we're going to do to solve? Help you out, I'm going to draw a picture. Let's say that we have a square. And in a square, we have 4 equal sides. I'll show it by those dashes. Perimeter is found by adding up all the sides. So if each of these side lengths is L, I can find the perimeter by adding all those together. So my perimeter could be equal to L plus L plus L plus L, or just simply as 4L. Okay, so I can write a formula to express the perimeter of a square. Now my goal is to solve for L. I know the perimeter is 66, so I can put 66 in for the perimeter. My goal is to solve for L, so the last thing I need to do is just divide both sides by 4, and then I would figure out what the length is. In this case, the length should be 16.5, and then I'm going to express the correct unit. Since it's talking about perimeter in feet, it would be 16.5 feet for the length of that side. Okay, so in this case, I had to identify what the variable is, show what I'm given. I drew a picture, used my picture, my understanding of perimeter to write an equation. I then plugged in any numbers I have to solve for my unknown variable. All right, same thing. So here we have a board 60 inches long. It's cut so that the length of the longer piece is 3 times the length of the shorter piece. How long is the shorter piece of the board? So in this case, I have two things, the longer piece and the shorter piece. Again, I can define this any way I want. So I will say here, I'm just going to use x. Because again, we always don't understand like what we could do. Just use x because we're kind of familiar with that. So x, what's that going to represent? X is going to represent what I'm trying to find out. It says how long is the shorter piece of the board. So I'm going to say that x represents the length of the shorter piece. So I'm going to define what my variable is first. Now what I have to do is I have to come up with a formula and equation. To help understand this, I'm going to draw a picture. We have a length of board. That length of board is 60 inches total. Okay? We're going to cut it into a longer piece and a shorter piece. Boom. So right here, this is going to represent where I'm cutting. So I'm going to cut there. Okay? The length of the shorter piece is x. My longer piece, it says, is 3 times that length. So how can I represent that? Well, if I labeled my shorter piece as x, I can label the longer piece as 3x. Okay. Now, how do I take this then diagram and represent this as an equation or formula? Well, I know that x and 3x, those two pieces, when combined, should equal the overall length of 60 inches. So I can write a formula like this. If I take x and add to it 3x, I should get, whoopsie daisies, not plus, I should get 60 inches. Okay, that the two lengths added together should equal the overall length. And now I can solve this. This is just an algebraic equation. So x plus 3x would combine to give me 4x. I can simplify that. And then lastly, I can solve for x by dividing both sides by 4, and x would give me 15. Okay. Now in terms of the problem, x is going to represent 15 inches, and that would be the length of that shorter piece. And I can also find the length of the longer piece if I wanted to by doing 3 times 15, which would give you 45 inches. Okay, so I defined my variable. I here, again, drew a diagram to help me understand the problem, wrote an equation, substituted, and solved. All right, next one says the length of a rectangle is twice its width. Its perimeter is 74. Find the dimensions of the rectangle. It says find the dimensions. What I want to know is I'm going to find what is the length and the width. I'll put as L and W. Next, I need to define a variable. So what am I solving for? Well, I'm finding both of them. Okay, so I just defined L and W as the length and width. Somebody just write that down. So I'll say here that L represents the length of the rectangle and W represents the width. Okay, so I'm going to draw a picture to help make sense of it. Here's a rectangle. Here's my width. Here's my length. And I know that the perimeter is 74. So again, perimeter is found. The perimeter is found by adding up all the sides. So in a rectangle, the two lengths are the same and the two widths are the same. So to find the perimeter, I can take 2 times the length and add to it 2 times the width. Okay. Now what you are given in the problem, it says here that the length of the rectangle is twice the width. Now here's the issue. If I take my perimeter of 74 and plug it in here, it's hard to simplify or solve this equation if I have 2 unknown values. So the problem like this kind of goes back to what we did in the previous problem, is I need to write one variable in terms of the other. If the length is twice the width, instead of writing L, I can write it as 2W. Whatever the width is, if I multiply it by 2, that would give me the length. So that means instead of using L in this formula, I can replace L with 2W. So it'd be 2 times 2W plus 2W. Now simplifying that, I would have 4W plus 2W. Again, I multiplied the 2 and the 2, which means my perimeter can be found by taking 6W, so 6 times the width. Now knowing that my perimeter is 74, I can go ahead here and find the width by just taking 74 and dividing both sides by 6, and that would tell me what my width is. And what I would get for a width is I'm going to get about 12.3 repeating, and this is going to be feet. All right, now, just because we've been doing this, well, 12.3 feet, let's express that in terms of feet in inches. Okay, so 12.3 repeating. The 3 repeating is like saying, right here, right on the side, it's like saying 1/3. So that'd be like saying 12 feet and then 1/3 of a foot. If I multiply that by 12, that would tell me how many inches. In this case, it'd be 12 feet, 4 inches for my width. Nice. And now I know my length is twice of the width. So if I want to find the length, I'm going to take 2 times the width. So my length will equal 2 times 12 feet 4 inches. And that would give me a length of 24 feet 8 inches. And shebang shabop, we are done there, folks. So this one a little bit more involved. Again, I had to define what my variables were. I drew a picture to help me understand. I then wrote a formula based on perimeter. I've substituted things in, solved. I had to convert my units, and then notice here I also had to solve kind of a secondary problem within that first one. Sassy but classy. All right, these last two problems, we're going to step it up a notch. It's going to be a little bit sassy. You probably have seen problems like this before, so I'm going to show you guys how we can write this, again, using a diagram and an equation. So you have two airplanes, leave a terminal about 1,900 miles apart and travel towards each other. Now, I'm not good at drawing airplanes, but here I have, let's say I have an airplane here, and I have an airplane here. The distance between them is 1,900 miles. So I'll draw a little picture. One plane says they're traveling towards each other. So one plane is traveling to the right, one plane is traveling to the left. All right, it says the average speed of the two planes are 600 miles per hour and 350. So I'll just say that this one here is 600 miles per hour, and this one is 350 miles per hour. I want to know at what time will the two planes pass each other. Okay, so my goal is to solve for time. So I'm going to say right here that t. Let's let t equal, so t is going to equal the amount of time it takes for the planes to, I'll say, meet. So they're going to cross each other. They're going to meet somewhere. They're going to meet somewhere within this distance. Okay? My goal is I got to figure out where the heck they are going to meet. Now, in order to do this, here's what we got to understand. If this plane, as I labeled 600 miles per hour, is traveling faster than this plane. So if this plane is traveling faster, it's going to move a little bit further. If this plane is moving slower, it's not going to travel as far. So I can kind of relate this to using the distance equals the rate times the time. It's a formula we talked about way back in one of our early sections, okay? Where the rate is going to represent the speed of the plane and the time is going to represent the time that it takes for that to travel. Here's what we know, that the time for both is going to be the same. So the first plane was set up like this. I'm going to say that the first plane is going to travel a distance, and I don't know the distance, of 600 times t. Whatever t is, I don't know, but that's what I'm going to try and find. The other plane is traveling at 350 times t. Okay? Now, here's what I'm trying to do is I'm trying to figure out the point where they meet. Now, there's one piece of information that I need to take into account, and that is the spacing between the two planes, 1,900 miles. Okay? I need to include that somehow, and here's the way I'm going to think about it. Treat this plane on the left side. Think of this as like a number line. Let's say that this plane is starting at a location of 0 miles. And this plane all the way on the right side is starting 1,900 miles away. So let's say it starts at a position of 1,900 miles. So what I would do is for this first part, this plane is traveling at 600 miles per hour a certain time, and they start at 0. The second plane is traveling at a speed of 350 miles per hour, traveling over a certain time, but they're starting 1,900 miles away from the other one. So what I'm going to do is I'm going to add 1,900 to that value. And then there's one other thing I'm going to take into account. One plane is traveling to the right, one plane is traveling to the left. So to kind of distinguish between right and left, I'm going to leave this 600 miles per hour as a positive, but I'm going to change this 350 miles per hour to a negative. Now I'm trying to figure out how much time it takes for those two things to meet. When they meet, they're in the same location. So here's what I'm going to do. I'm going to take these two expressions that I wrote, and I'm going to set them equal to each other. So it's going to look like this. 600t plus 0, I don't need to include that, is going to equal negative 350t plus 1,900. And my goal is I'm going to solve for t, and that should tell me the time it takes for the two planes to meet. The first thing I need to do is combine my t's. I'm going to take first and add 350t from the right side to the left side, just like I would in an equation. That would give me 950t equals 1,900 miles. Okay, then I can take that 950, since I'm solving for t, and divide it out. And that would allow me then to solve for t in the end. And I would get a total time of 2. And since we're talking about miles per hour and miles, that would be a total time of 2 hours. So it would take the planes approximately 2 hours, not approximately in this case, exactly 2 hours for those two to meet at that distance. And the problem doesn't ask for it, but now that I know the time, I can figure out where the two planes would actually, or not where they would meet, but I could actually figure out the distances they traveled as well using their two individual expressions. But this is just asking at what time would they meet. Sassy, sassy, sassy. Okay, next problem, similar but different. So it says here, at 12 o'clock p.m., the two planes leave the terminal located 2,500 miles apart and begin traveling towards each other. The speed of one plane is 1.5 times the speed of the other. They pass each other at 4 o'clock p.m. What is the speed of each plane? Okay, so instead of finding t, so in this case I use t, I'm going to say r. I'm going to say r is going to represent the speed of each, or sorry, I'll say the speed of one plane. And if I know the speed of one plane, I can find the speed of the other. It's kind of a similar diagram again. I have two planes traveling towards each other with an unknown speed this time. Okay, they are separated by a distance of 2,500 miles. I can set this up almost the same way. They're again going to meet somewhere in the middle. Now, I don't know the exact time, rates or speeds, but I do know that one plane is traveling faster than the other. So let's say that the slower plane over here on the right side, let's call that speed r. It says that the other one is traveling at 1.5 times the speed of the other. So this plane would travel at 1.5 r, where r again is going to be the speed of the one plane on the right. Now my equation, I'm going to set this up the same way I did before. I would take plane number 1 on the left. I would have 1.5 r times the time it takes. Now the time it takes, it goes from 12 o'clock p.m. to 4 o'clock p.m. So unlike the last problem, I know the time. The time is going to be 4 hours. Okay? So whereas here I had to plug in t for time, here I don't know the rate, but I do know the time. That's going to be equal. I want to figure out where they meet. So I'm going to do here negative r. Why negative r? Because this is moving to the left. So let me put a minus up here. It's moving to the left. So minus r times the time it takes, again, is 4 hours. But then I'm going to do plus 2,500. So all I'm doing is I'm setting up the same problem I did before, but I'm using r to represent the rate, where here I knew the rate. So it's a little bit weird. Okay, let me simplify this out so it looks better. I have 1.5 times the speed, or the rate, times 4. So what I could do first is multiply 1.5 and 4, and that would give me 6. So that'd be like saying 6r equals. I would have negative 4r. Okay, it's just negative r times 4 to give me negative 4r plus 2,500. Now it should look a little bit better because I can solve for r by adding the 4r to the other side to get 10r equals 2,500. And then lastly, can divide both by 10, and I would get a rate of 250. And that would be 250 miles per hour. So that means the plane on the left side, ignoring direction, is moving at a speed of 250 miles per hour. So lastly, if I wanted to find the speed of the other plane, we said that the speed of the other plane is 1.5 times that rate. So I would do 1.5 times 250. And that would give me a speed of 375 miles per hour. Now, I didn't label this, but I guess I could just put here a capital R so I can show the difference. So one plane would be moving at 250 miles per hour, one plane at 375 miles per hour. So a little bit sassy on these last two, but this I had to write a little bit more complicated of an equation to solve for those unknowns. But again, the idea we talked about here today was being able to solve a written problem, identifying your variable, using a diagram if need be, choosing a formula or writing your own equation, and then using the values given to set up and solve your equation to find your unknown variable. Okay, good luck on the practice. If you have questions, jot those things down, and we will answer those in class. All right, good luck, and we'll see you next time.